So today we're going to look at transforming a function that's common, which is f of x is root x. So our base function that we're working with is root x. It's called a radical function. Okay. Now, to get the key points, we'll start our table of values with, like, say x is -2. Well, then when I go to f at -2 to get the y value, I get root -2. If you try that on your calculator, it doesn't work. Root -1 doesn't work either. You can't square root a negative number. So the first x value that we can actually use is 0. And the square root of 0 is 0. So we have a point at 0, 0. Then x can be 1. The square root of 1 is 1. So we have a point at 1, 1. Now if I plug in 2, the square root of 2 is like 1.41, blah, 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 blah. That's not nice. So we're not going to use that x value. We're also not going to use 3 because it doesn't give us a nice root, but 4 has a nice square root. Root 4 is 2. So 4, 2 is a key point. And then 5, 6, 7, 8 don't give us nice answers, but 9 gives us a nice answer. Root 9 is 3. So 9, 3, all right? And so that gives us our base graph of root x. And remember, square root means what's a number that I can multiply by itself to make 4? Here, what's a number that I can multiply by itself to make 9? 1 is a number that I can multiply by itself to make 1. So 1 squared is 1, 2 squared is 4, 3 squared is 9. So square root is the opposite of a square. So it says using the parent function f of x is root x, describe the transformations and write the equation of the transform function. So you can see there's two negatives here. There's a negative outside the function and a negative inside the function. So the negative outside the function we know is going to be a vertical reflection because it's happening to the whole function. All right, then the negative inside the function, that's going to be a horizontal reflection because it's inside the function, so it's horizontal, it's happening to the x's. Now, let's go back out here to that 2, and it's a 2 multiplying the whole function, which means it's vertical. It's a multiplication, so it's a stretch by 2. All right, let's look at this 1/3 here, because that's another multiplication, but it's inside the function. So inside means horizontal. Now it's a 1/3, but it's happening to the x's, so that means it's multiplying by 3. So it's a horizontal stretch by, and you can always figure that out by doing 1/1/3, and you can know that that's a reciprocal, or you can do it on your calculator, and that's going to give you a vertical stretch by 3. Okay, and let's look at the last things, the translations. So inside the bracket, the x plus 6 means, so first we know it's horizontal because it's happening to the x. It's a translation because it's adding or subtracting. And then plus 6 is going to be the opposite because it's to the x, so that means left 6. And then this last one out here, it's happening to the whole function, so it's vertical. It's subtracting 5, so that means it's a translation down 5. Okay? So let's look at turning this into an equation. So g of x is, now the whole function is multiplied by -2. So there's my reflection 2 times. And then instead of the f and then this whole function, I'm going to use our square root function. And instead of just x, we're going to have all of that stuff happening. So -1/3 x plus 6. And then outside the function, we have -5. So notice that I have my -2 And then my function is root. And then the inside is what we said, negative a third x plus 6. And then the final thing outside the function of minus 5 is outside the function. Okay? Now let's apply that to some graphs. So first we have to make a table of values for the parent function. So we know we're going to do 0, 1, 4, 9, right? We're picking numbers that have nice square roots, all right? So this is f of x is root x, right? And then we're going to graph that. So 0, 0, 1, 1, 4, 2, and 9, 3, okay? And then we're going to describe the transformations. So this is done, this is done. Describe the transformations. Well, multiplying the whole function by a half is a vertical, because it's the whole function. It's multiplying, so it's stretch or compression. In this case, it's a compression by 1/2. And then the plus 1 to the whole function is vertical translation up 1. Okay, so my mapping rule is nothing horizontal is happening, so x maps to x. So my x's are going to be exactly the same. And my y's, though, map to, well, vertically compressed by a half, so it's going to be a half times y, and then translated up 1, so plus 1. So my new y values are 0, so a half of 0 is 0, plus 1 is 1. A half of 1 is a half, plus 1 is 1.5. A half of 2 is 1, plus 1 is 2, and a half of 3 is 1.5, plus 1 is 2.5. So let's plot these. So 0, 1, so moved up by 1. 1, 1.5. 4, 2, so 4, 2, and then 9, 2.5. So this has been moved up by 1, and then it's been vertically compressed by a half, so squished, okay? So it's like, if I move this black graph up by 1, it would look like this, but then we compressed it down to look like that pink one, okay? All right, let's do this one. So here, again, 0, 1, 4, 9, root 0, 0. Root 1 is 1, root 4 is 2, root 9 is 3. So I'm going to plot that. There's my base. Now let's look at the translations. So vertical, reflection. Okay, so that's the only vertical thing that's happening. And then horizontal. So because of that 2, the x's are being multiplied by 2. So that means it's a compression, because it's always backwards, by 1 over whatever that number is, so 1 over 2. And then the x minus 3 means horizontal translation 3 up. Okay, so my mapping statements, x is going to map to horizontal compression by a half, so a half x, and then up by 3, plus 3. And then y is just vertically reflected, so negative y. So my x's are going to be a half x plus 3. So a half of 0 plus 3, that's 0 plus 3. A half of 1 is a half, plus 3 is 3.5. A half of 4 is 2, plus 3 is 5. A half of 9 is 4.5, plus 3 is 7.5. And then the y's are just going to become negative. So negative 0 is still 0, negative 1, negative 2, negative 3. So let's plot these new points. So 3, 0, 3.5, negative 1, 5, negative 2, and then 7.5, negative 3. So 5, 6, 7.5, negative 3. There you go. So there is a function that's been vertically reflected, horizontally compressed by a half. So that means it's been squished this way and then moved 3 units to the right. Okay? Now let's look at this one. So we'll do the same thing for our base. 0, 1, 4, 9, 0, 1, 2, 3. And I'll plot them 0, 0, 1, 1, 4, 2, and then 9, 3. And so there's our base graph. Okay. And now let's list our horizontal and vertical translations. So the 3 tells me that there's a vertical stretch by 3. The negative, one thing we have to do here is we actually have to rewrite this. We have to factor out that a half. So that'll be x minus 4, because when I divide 2 by a half, it'll be, but if I divide 2 by negative a half, it becomes minus 4. So that's just something we have to do because it has to be factored before we graph it, okay? So vertical stretch by 3. Horizontal stretch by 1 over 1 half, which is 2. And then the negative tells me that there's a horizontal reflection. The minus 4 tells me that there's a horizontal translation for right. And then the plus 1 tells me that there's a vertical translation up 1. Okay, so let's do our mapping statements. So my vertical mapping statement, let's do that first. So y is going to be stretched by 3, so 3y, and then up 1, so plus 1. Okay? And my horizontal one, it's going to be a horizontal stretch by 2 and a horizontal reflection. So x is going to map to reflection, negative, stretch by 2, 2, x, and then 4 right, plus 4. Okay? So let's make our new points. So for x, 0, negative 2 times 0 is 0, plus 4 is 4. Negative 2 times 1 is negative 2, plus 4 is 2. Negative 2 times 4 is negative 8, plus 4 is... negative 2 times 4 is negative 8. Negative 8 plus 4 is negative 4. 9, so negative 2 times 9 is negative 18, plus 4 is negative 14. So that's my x's. And then my y's are 3 times y plus 1. So 3 times 0 is 0, plus 1 is 1. 3 times 1 is 3, plus 1 is 4. 3 times 2 is 6, plus 1 is 7. And 3 times 3 is 9, plus 1 is 10. So let's plot these new points. 4, 1, 4, 1, 2, 4, 2, 4. Negative 4, 7. And then negative 14, 10. So see how at this point, you can see that it's the same family of functions. They look similar, but all those transformations combined make it look quite unrecognizable. It's pointing in a different way. It's stretched, compressed, all kinds of different things are going on. Okay? So that's transforming root x.